This is an example of using the logarithm properties to simplify a log expression so that if we do have something that has several logarithms in it, we can rewrite that as a single logarithmic expression, which we talked about being important for solving logarithm equations. So let's first see how to simplify a log expression until it looks like just one single log, and then we'll see an example of that being used to solve an equation. So in this problem, we're trying to simplify an expression that has more than one log, and we're trying to, simplification in this case means that we would like this to look like just a single logarithmic expression. The log properties that we talked about before are summarized here, and so we can see that this has structure that's similar to the log properties on the screen, but we have to be very careful that when we are using log properties that we really are using real properties and not sort of variations on them. So for example, there isn't a property that says how to add twice a log plus a log. None of these properties talk about that. This one talks about adding two logs, but there's no numbers out in front, and so it doesn't exactly match this scenario. So what we can do, though, is use this idea first. So why do I have a crayon? So this idea first, because we do have a number 2 outside of a log expression, and that matches the right-hand side of this rule. So if I apply the rule here, and it'll feel a little backwards, but instead of thinking of a power being pulled outside of a log, we can think of if a number is multiplied by a log, then that number can be pushed inside. So in this case, 2 log base 3 of x plus 1 is the same thing as log base 3 of x plus 1 squared. And of course, this is the entire argument here. So the rule is applied by pushing the 2 inside the parentheses, so now that it's on the power. And you can see now, if you thought about it as the 2 being pulled outside, it would match that side. Now that we also have plus log base 3 of x, still left from the first line, but now I really do have the log of one thing plus the log of the other, and so now that does match the right-hand side of this first rule. And so the log of a sum is just the log of a product, so I can rewrite this as x plus 1 squared times x. And that would be a single logarithm expression that's equivalent to this original. So this would come up in a problem, something like this. I have the instructions solve the logarithmic equation, and you can see here the log is base 10 log. There's no base there, which means we assume that it's base 10. But I have multiple logs. So my solution strategy would be to try to get a single logarithm on the left-hand side. So I'll do that by first getting all of my log expressions on the left-hand side. So I'm going to subtract on both sides in order to have the left-hand side with all of the logarithms in the problem, and the right-hand side we'll just leave as a number. You can see I have the log of one thing minus the log of another, and so that matches the right-hand side of the second logarithm property. So I can rewrite that as the log of 8x plus 3 over x minus 8. So again, I'm just using log properties until it looks like the log of something equals something, where I only have one logarithm over here. Don't forget this is really base 10. And so now I can just rewrite this in exponential form. Because I have a log base 10, that's equivalent to an exponential expression base 10. And here the input into the log is 8x plus 3 over x minus 8, this kind of complicated thing. Over here, that's going to be the output of the exponential expression. So the exponential function will have an output of 8x plus 3 over x minus 8. The log expression had an output of 1, so in the exponential expression, the input will be 1. So these two equations are exactly the same thing. The logarithm equation is equivalent to the exponential equation, but the exponential equation is easy to solve. To solve an equation that has 10 equal a fraction, the easiest thing to do with fractions is to multiply both sides by whatever it takes to get rid of the fraction. So in this case, if I multiply both sides of that equation by x minus 8, then on the left side I'll have 10 times x minus 8. On the right side I'll have 8x plus 3. So now the fractions are gone, and I have a simple linear equation to solve. And if you do the math, we'll end up with 2x on the left side and 83 on the right side, of course. What else would it be? So the answer here is x equals 83 over 2. And I really should check that back into the original equation to make sure that a log of a negative number doesn't happen. Obviously, it doesn't happen there. That'll definitely be a log of a positive number. 83 over 2 is like 41.5, so even on this side, it'll be the log of a positive number. So it doesn't cause a domain problem with the original equation. Might be smart to check it anyway, but I feel pretty confident that that's the right answer.